right? Okay, I'm going to do on distance, speed, time graph. This is actually one of the part of the chapter in the Sec 3 graph chapter, okay, for practical situation, but I think it's more often than not very common in N level, but once in a while it appear. So it appeared in one of the 2021 or 22 paper. Okay, so let me just go through the main few key points. Number one, for distance time graph, distance time graph looks something like that. There are two types of distance time graph. The first type is
Don't have.
which one don't have?
Don't have.
Don't have the screen, is it?
Yeah.
Eh, yeah. Oh, can see now? Is it
Yeah.
okay? Can
Yeah.
see already. Okay, thank you very much. So for distance time graph, right? Distance time graph, there are two types of distance time graph. One is the distance. This kind of distance, it will keep on increasing. It's the total distance that you travel against time. Another type of distance time graph is distance from a fixed point. So for this kind, the distance can go up and then come down. So because like when I go up, when I go to a fixed point from away from the house, my distance increase. But when I return home, my distance will decrease. So there are two different type. Okay, next one, then what do we know about distance time graph? What can we usually find? The gradient of distance time graph, gradient is given by the formula. How to find formula for gradient? How to find formula for gradient?
Y2 minus Y1
Correct.
over X2 minus X1.
Very good. So y2 minus y1 in this case, where I look at my y, observe the y units over here. This y units is the y-axis is my distance, the units. And then my x-axis, what is on my x-axis? What's the unit for my x-axis? Okay, the unit for my x-axis is the time taken. So in this case, this one is distance divided by time. Distance divided by time. So the gradient of the distance time graph tells you what? What does it tell you? What is distance divided by time?
Speed.
Yes. Okay, so it gives the speed of the article of the point at that particular point, right? Then next thing is average speed. Average speed is given by the total distance traveled divided by the total time taken, right? Even if there's rest or whatever, also must include the time taken. So without further ado, let's try to apply this concept. This graph shows Dylan's journey from town X to town Y. So he travel A. What does a straight line? We all study physics, right? Straight line means what in your distance time graph? Straight line means what kind of speed?
Constant speed.
Very good, constant speed. Then I have this portion that is a flat line. It's straight line, but it's flat. Did the distance increase? What
No.
happened to no? So what happened to the speed at this point?
Constant speed.
Constant speed, but is there any speed at all?
No.
No, for this one will be zero speed. It is at rest. Okay, so for this portion, this one there is a constant speed. This one also got constant speed, right? So first part, find the gradient. They ask you to find the gradient already, right? Gradient of the line segment AB. So it's between these 2 points. So what do? We find the gradient. The number over here, this is 1, 100, or rather the height, which is 100, divide by my base over here. This one is 1 hour, right? Units is hour. So in this case, I can have my gradient. This one is 0, 0. So I find my gradient. First one, what does the gradient means? The gradient y2 minus y1, 100 minus 0. 1 minus 0 gives you the answer 100. Are you able to tell me what is the units in this case?
Kilometer per hour.
Very good. So this one will be kilometers per hour, right? So in this case, what does it state? What does the gradient tells you? What does it represent? It means the person. This one is who are Dylan. Dylan is traveling at, not the particle already, is Dylan. Dylan is traveling, and just now you all say straight line is what kind of speed?
Straight
Straight line,
line
right?
is
I want
constant acceleration.
constant acceleration. That one is for speed time graph. This one will be just constant speed will do. Okay, is traveling at a constant speed. Y'all can revise physics at the same time. Of 100 kilometer per hour. All right, so keywords, you need to write constant, traveling at constant speed, one, then number the gradient. Okay, next one, how long did Dylan rest during the journey? Where's the portion that he rested? A to B,
100.
B to C, or C to D?
B to C.
B to C, right? So how many hour? What is the time?
3 hour.
Is it 3 hours, sure? Between 1 to 3. 2 hours. So he only rests for 2 hours, right? How much time did Dylan take to travel 150 kilometers? They give you the 150 kilometers. So what do? You go to the distance, the 150 kilometer, do what? We draw line, dot, dot, dot. How long did it take, right, to travel? Then find the answer. Alamak, this one is in units. So this one is 3.4 of an hour, right? So either we change it to 3 hours. How to change the 0.4 into how many minutes? 1 hour, how many minutes?
60.
So 60, take the 0.4 times 60. So it'll be 24 minutes. So this is the time taken by Dylan. Can? Alright, so this one the very basic one. We do one more type of question. This one is the distance keep on increasing one. This one is just distance, right? The next one we're going to do is distance from a point. So it goes up. The distance can also come down because the person returned home. So the distance measured from his house, right? So first part of the question, we have to interpret a little and match the scenario. Question says, Shane cycle from home to post office. So he start here home, then he cycle. Can you tell me what is at point A?
20.
20, the distance, right? So this point A, he stopped, right? So on his way home, so before he go there, have he reached the post office already? So this is the part where he reached the post office, right? Correct. So first part of question is, how far was the post office away? So just now somebody said the answer already. How many kilometers?
20 kilometers.
Correct. Very good. 20 kilometers. Then on his way home, he stopped at a food center. So now what happened? You notice the distance drop, right? It's not that the speed is negative, but that the distance is a different direction, is coming home. So when on his way return home, he stopped by at the food center. So where is the food center? The food center is between C to D, this timing here. Okay, then to have his breakfast. Then after that, he travel home, correct? Find the total time Shane stayed at the post office and the food center. So they want the timing from here to here. And where's the food center?
B
A,
to,
B,
B
B
to
to C. B to C, B to C is traveling. Where did he
C to
stop
D.
to?
D,
Where
D.
did D. Which one? What again?
C to D.
C to D. So he sit down there and eat, right? So eat, there is 0 speed. So in this case, we're going to find the timing. This one is 8 to 9, which is 1 hour. So this one is 1 hour plus this one from here. This timing is what? This timing is 9:30 to 10. So it's another 30 minutes. So answer straight away 1 hour 30 minutes. Okay. Next part, find the gradient of the line segment OA. How do we find gradient?
Y2 minus Y1, X2 minus X1.
Correct. They want O to A, right? So O to A over here, this point is Y2 minus Y1. Oh, what is this number? This is 8 o'clock. Who is this that's here? All right, this timing here is 8 o'clock. The distance is 20. The timing here is 7. The distance is 0. So we take the gradient, the height, or rather in this case, we find a triangle. Okay. Hello, yes. Right? So I have a triangle. So the height divided by the base. So in this case, my triangle over here, this one, the height is 20 minus 0 over base 8 minus 7. Remember, this is kilometer, this is hour. So we have 20 kilometers per hour. State clearly, what does this gradient represent? Something similar to what we answered just now. This one is who? This one is, this person is Shane, right? So Shane cycled at what kind of speed? Straight line, what kind of speed?
Constant.
Constant speed of how much?
20 kilometers per hour.
Correct. So answer, so Shane cycled at constant speed. Important, must write the description. Constant speed, explain. There's a difference between constant speed and average speed. Average speed, the curve, the number, the line may not be a straight line, can be a curved line. Okay, so cycle at constant speed of 20 kilometers per hour. Can? Right, we do one more distance time graph before we go on to speed time graph. Now, this distance time graph, observe, although the question say is a distance, right? What do you notice? The distance go out and then it come down. Can you have negative distance?
No.
No, right? So that means this is actually this driver, he went out, then what happened to him?
He rests.
He rests, then after that, what happened? What happened here? So this part is he go out, then this part here,
Come down.
He come down, he go back home, right? So this is my answer. Then he said he rests, right? How long did he rest? The question asks, how long did he rest? From what timing?
2 to 7, 4.
2 to 7 is 4. 2 to 7 is how much? 7 minus 2?
5.
5. Okay, in hours, so 5 hours. Okay. What paper you all have tomorrow? Mother tongue paper? Or what?
They got English LC.
Okay. If he start the journey at 7:30, what time did he reach his destination? How long did he drive and then after that come back again? How many hours in total?
10 hours.
10 hours, right? So it started at 0730. 10 hours later, it become 1730. So 5:30, then he come home. Okay, but he drive out all the way so long. Okay, so answer 5:30. Now, next one, find his average speed. Average speed is given by total distance over total time. Can you tell me, did he drive a total distance of 0? He go out, then he come back again. Is it 0 or is it 250? Or what else must I do?
At rest.
At rest. So at rest, did he travel any distance?
No.
No, right? So he travel out how much distance?
250.
250. Then after that, what else must I add? He only travel this distance or what other distance did he travel?
Go down.
He go down, right? Then also when he travel like that, what is the distance he take to travel home also?
250.
Another 250. Then what is the total time taken?
10 hours.
10 hours. So in this case, this one will be 500 kilometers divided by 10 hour, 50 kilometers per hour. Find the gradient of the line segment. In this case, this gradient is going downwards, right? So what's the gradient of the line segment? What is this number?
7 and 250.
Then this one here?
10 and 0.
Yes. So we find our gradient. Y2 minus Y1. Then the other one, X2 minus X1. How much is this? Not a nice number. I will leave it as a fraction, okay?
It's a negative though.
Negative,
Yeah.
Okay, correct. So in this case, why is it negative? By right, my speed cannot be negative, but why? What is this so special about this negative sign? What does the negative sign tells me? Is it that a deceleration? Deceleration is for speed time graph. This one distance time graph. This one is the gradient is the speed. But what does this negative tell me? Remember, what kind of graph is this? The distance go out and can come down. When it come down is what? Are they traveling in the same direction? Then this one when it's going upwards, is traveling out, right? Then when he traveled this way,
Down.
He's going out, or is he coming home?
Coming home.
Coming home, right? So it's going in the opposite direction. So this negative sign tells me he is returning home, right? The direction. So the speed still stays at positive number, but the driver is returning home. So this is what the negative sign means. At a constant speed of 83 1/3 kilometers per hour. Notice here, when we write the speed over here, no more negative sign. Okay, because the negative sign go where already? It is returning home down here already. Is this okay? So this is for distance time graph. Okay, the distance time graph, the main key points to take note, the gradient tells you the speed. The average speed must take the total distance divided by total time. Next one, if you're okay, then I'll continue to the next part. I'm going to do this one a little bit slower. This is speed time graph. Speed time graph got a couple of different answers, things that we can do. Number one, speed time graph can help me to find the distance. Okay, how to find the distance? Normally, distance is to take speed times time, correct? So if let's say, for example, I take 20 times the time 10, is it constantly traveling at 20 all the time? Or is it sometimes got different speed for this portion?
Sometimes got different speed.
Correct. So in this case, if I just take the number speed times time, 20 times 10, it will become a full square rectangle. But no, I only travel half of the rectangle. So what I need to do when I want to find distance is actually the area under the speed time graph. Okay, is to find when it's distance, we find area under the speed time graph. Then just now, distance, the gradient up one level tells me the speed. Okay, so the distance, I up one level. When I find the gradient, I up one more level, tells me the speed. So if now I have a speed time graph, I want to find the gradient. Gradient is given by y2 minus y1 over x2 minus x1. Can you all tell me what is the units for my y? What is the units for the y? Speed. Somebody say speed, right? Or meter per second, or rather speed, right? Okay. Then what is the units for my x-axis?
S.
S, which is my second, or rather my time, right? So looking at the units, observe the units here. Meters per second divide by second. What do you get? Meter
Meter.
per second? No, we don't get meter.
Oh,
We multiply, then we get meter per second
square.
Yeah. So what is meter per second square? What does meter per second square tells you? Meter per second square is the unit for which one? You all study physics, you all also know, right? Meter per second square is unit for what? Meter per second square. Ayo, you cannot remember. This one tells you starts with A.
Acceleration.
Yeah. Okay. So in this case, when you have the gradient of the speed time graph, the what tells you the acceleration. So for speed time graph, the gradient tells you the acceleration. Yo, who is this? Rahil, too late. Rahil, you're on the wrong Zoom. That was the Sec 3 Zoom. Sec 3 Zoom was at 7:45. You missed it already. Right? So acceleration speed is for acceleration. You find the gradient, you find the acceleration. But if I want to find the distance, it's area under the graph. Right? So one, you find the gradient, the other one, I find the area. Then how do I find speed? Finding the speed, average speed, or this average speed, I need to take the total distance divide by the total time taken. Okay, so with these 3 key points, we slowly find out the answer. First type, notice that the speed goes and then come down again. But for speed, cannot have negative speed. So what does this actually mean? This actually means the speed increase. There is a constant acceleration. Then what about this portion?
At rest. Constant speed.
Is it at rest or is it constant speed?
At rest.
At rest is for distance speed time graph. Just now you said the answer. So is at rest or is it constant speed?
Constant speed.
So this one is constant speed. Constant speed got movement. It's not at rest, okay? Well, speed has a number, it's not 0, right? Then what happens to this portion? What does it mean?
Deceleration.
Correct. Constant deceleration. Okay, constant deceleration. So in this case, question asks me for what is the acceleration of the object at 15 seconds? So 15 seconds, where is 15 seconds? 15 seconds is at this period of time, right? 15 seconds is here. Okay. Is there any acceleration?
No.
No acceleration, right? So what is the acceleration? If there's no acceleration, then what is the acceleration value itself?
0.
0 meters per second square. So no acceleration at this timing. When they give you a timing, it's looking for the whole line segment. It's not just one particular point on its own. It's the whole line segment. So at this point, there is no acceleration. The acceleration is equals to 0 meters per second square. Next one, find the speed when t equals to 8. Where is t equals to 8? I have to estimate a little bit, timing 8, right? So where is the speed? The speed is at this portion. I need to find this part. this speed, correct or not? Now, problem is, this speed is actually along the same straight line, correct? Okay, so how do you find this number here? I don't know. But what do I know? I can see that there's another triangle over here. Do you see the triangle?
Yes.
Do you see this triangle? What is the height of this portion of the triangle? This one, how much?
20.
20. Then what is the base here? This one, how much?
10.
10. It lies on the same straight line. So I actually have a similar triangle, correct or not? What is the height here? The height here, I do not know. I want to find. Let me call this portion x value. Then what is my base here?
8.
8. So what do I know? My height over my base, which is the gradient, the height equals to the height over the base, which is also a gradient. Why is it so? Because all of them on the same straight line, so they have the same gradient. So I'm going to use my height over my base equals to the next height, which is x over the 8. They are on the same line, same gradient, right? What is the value for x?
2.
Got 2. Are you sure 2?
Wrong.
What do you need to do now? Cross?
Cross no meh?
Cross what?
Cross multiply ah.
Cross multiply 160. Then this one is 10x. Then x equals to how much? The rest all suddenly keep quiet. Only Lin, one person answer everything. Very poor thing. What are the rest of you doing? So x is equals to 16. So this is the speed. I explain this portion again. The question asked me to find the speed at time 8. So what I'm going to do, I'm going to draw. I need to find what is this speed over here, right? This portion. But I notice that this is on the same straight line. So what I do, I extend and I look for a triangle. Okay, so the speed in this case is all the same throughout. This constant, not same throughout, constant acceleration, sorry. The gradient is the same. So it's given by height divided by the base equals to the height divided by this base. Okay, so we find the answer 16. So therefore the speed will be 16 meters per second. Are you okay with this portion?
Yes.
Can, huh? Okay, then I found acceleration, I found speed. The next one, find the value of k with total distance. How do we find distance? Distance is the area under the speed time graph. They tell you the total distance traveled. So it is the area under the whole shape here, this whole thing, right? What is the name of this whole shape?
Trapezium.
Very good. So this is a trapezium. Trapezium have two parallel sides. What is this length over here? From 10 to 25. What is this length?
20.
Is it 20? Check again.
15.
15. 10 and 25, right? So 10 to 25, 15. Then, do I know what is this length? They want me to find, right? What is this value? The whole thing 0 to what letter?
K.
K. So this part is K. Then where is my height of the trapezium? Where's the height of the trapezium?
20.
Where's the height? 20. Here, right? This one's my height, right? So the height, how much?
20.
20. So total distance is given by area under the graph. So the distance equals to the area, which is the trapezium. Formula for area of trapezium?
Half A
Mhm.
plus BH.
A plus the B, which is the letter K, times the H. But now, do I know the distance, the number? This distance changed to what number?
450 meters.
Correct. We put 450 inside here. First step, how to get rid of the half?
Times
Times 2. Wait, I forgot this one. The number here, the height is 20. Okay, so first one, we multiply this times 2. 450 times 2 is 900. Equals to 15 plus k times 20. How to get rid of 20?
or divide.
Divide. So 900 divided by 20?
45.
Okay, 45 equals to 15 plus k. What is k?
Move 15 over minus
Minus, so 45 minus 15, how much is k?
30.
30, answer. Okay? I repeat this portion again. Total distance. Distance is the area under the speed time graph. This area, this shape is a trapezium. So half A plus B times the height. Okay, so I already know distance is 450, put inside. Then get rid of the half, get rid of the 20, find the answer. Can? This one, this portion, this type of question quite important. Okay, I know you might be a little bit tired. Last question already, question number 5. Then we can call it for today. All right, the diagram below shows speed time graph of a particle moving in a straight line. Okay, then what can you tell me? This portion.
Constant acceleration.
Well done. This one,
Constant speed.
correct. Then this one?
Constant deceleration.
Very good. Okay, so the question now says calculate the acceleration of the particle during the first 15 seconds. They want the acceleration. Acceleration is given by the, how to find acceleration?
Gradient.
Acceleration. Gradient. Gradient can I only find 1 point or I need 2 points to find gradient?
You need 2 points.
2 points, right? So I need 2 points to find gradient. The question tell me during the first 15 seconds. I tell you, they're trying to trick me. They want first 15 seconds, but 15 seconds, I got no point, no value, correct or not? So when I have no point, no value, I know acceleration must look for the gradient. Gradient need 2 points, right? So my question, this line, this point is on this line. Am I going to use the 15? Is the 15 useful?
No.
No. Then what point should we use?
Top and bottom.
The top and the bottom. What is the number at the top here? 20, 30. Then the bottom one? This one 0, 0.
0.
Yes. So what is the acceleration? The gradient in this case is y2 minus y1, x2 minus x1. Answer, is it 1.5? Okay, 1.5. I think so lah, based on my math skill. Okay, so in this case, gradient, but observe unit. This is meter per second. This one is second. What is the unit for your acceleration?
Meter per second square.
Correct. So this one, the gradient will be meters per second square. So therefore, acceleration okay. Next one. This one still okay? Can So don't get tricked. They say, although they say 15, but 15 is useless. So it's actually this whole point. So need to look for 2 points. Okay. Part B. Calculate the distance moved by the particle in the first 65 seconds. Question 1. Distance. Very good. We need to find area under the graph. So distance of speed time graph, find area. They want up to 65 only. So up to 65. What is this whole area?
half A plus BH.
Also can, or some of you prefer you find area of triangle plus area rectangle also can, no problem, okay? So for me, I think some of them, they will do area of triangle lah. Okay, so if I want to do area of triangle, this one is half times 20 times 30. This one area of rectangle, 30 times this number, okay? But if not, then I'll do area of the trapezium, also can. Either you find triangle plus rectangle or you find area of trapezium. So
45.
area, yes, I can 45, 30 times 45. Good, So in this case, I will find distance is half, 45. Just now somebody say already, this one to this one, 45. Plus, they want 65 times the height here. The height here is 30. Anyone count for me the distance? Wow, who is here? I'm at the last question already. Oh, Jinxi. Jinxi, our remedial starts at 9. Later then you come back can again. This one
1650.
1650. Thank you very much. But what is the unit? Speed times time.
Per second.
Speed, distance. I'm looking for distance. Speed times time.
Seconds.
Second, you say is the unit for distance or not?
Okay, meters.
Meters. So the distance is 1650 meters. Can?
Yes.
Alright, good. Next part. Okay, the last part already. The particle decelerate. Decelerate. If it's deceleration, can you tell me what is the gradient? Is it positive 2 or is it going to be negative 2?
Negative.
Negative 2, right? But they tell you the word decelerate, right? So when it's deceleration, it means the gradient of the line tells you deceleration, gradient is negative 2. Where is the deceleration? Which portion?
65 to T.
Correct. So this portion is my deceleration. How to find the gradient? They tell me the number here. They tell me gradient already. So do I use, which one do I use? I need 2 points. Which 2 points? Suddenly keep quiet. 2 points. Where are the 2 points? The top and the bottom, right? So the top of the line, this one is what point?
65 and 30.
Correct. Then this one over here is what point? T, comma, 0. One person whisper very softly. Okay, so they tell me gradient y2 minus y1, x2 minus x1. What is the number to put in for my gradient?
30.
Okay, 30 is the working here. 30 minus
0.
0 over
65.
65 minus
T.
t. But what is the number for the gradient? What to put here?
Negative 2.
Very good. Use negative 2, not the number 2, but negative 2. So we plug this inside here. So we're going to use the gradient negative 2 plug inside. Okay, let's simplify our equation a little bit. Negative 2 over 1 equals to 30 minus 0 is still 30. 65 minus t. So what do? We cross multiply. Negative 2 times 65 minus t. Then this is 30. Expand out. What is this number? 130. This one times this one. What is this number? Correct?
Yeah.
Okay, then how find t?
Move negative 130 to plus 130.
So 30 plus 130, 2t equals to 160, t equals to
80.
80. Answer. Is this okay? So now
Madam,
this is, yes.
how you know the gradient is -2? I don't understand that part.
Okay, this part, right? Here, the question, the keyword say decelerate. Deceleration. So what kind of gradient will be the deceleration? Going up or going down?
Going down.
Going down, right? So going down is actually looking at this portion, correct or not? So if it's going down, the slope, the gradient going down, is the gradient positive number or negative number?
Negative number.
So the negative sign come from the word decelerate over here. Can? But they tell you, but acceleration itself is just a number, so it's 2 meters per second square lah, but it says decelerate, so it's the -2 over here. Can you understand how we get a -2 already?
Yeah, thank you.
Okay, can. All right, if that's the case, then we end off for today. No other questions already. If you have time, some of you wanted changing subject formula. I can do changing subject formula for revision tomorrow. All right, 49 minutes, 50 minutes for today. Thank you very much for attending my lesson.
Thank you, ma'am.
Bye-bye. All the best for your exam.
Thank you.
Bye, Madam Ng.
Bye.
Thank you.
Bye-bye.